right? So our goal was to show that whatever we have got using reach t, that is actually win1, right? So we are just saying that if you pick a vertex which is not in reach t, right, then there is a strategy for player 0. Yeah, then there exists a strategy for player 0, yeah, which means if player 0 plays with that strategy, then no matter what strategy player 1 uses, okay, which ensures that, when I have to just write it, which ensures that, which ensures the run, which ensures, just say that the game never reaches T. Without technical language, never reaches T. Yes. The vertex starts at V, but the vertex never, the token never reaches to anything in T. This is actually also not difficult. Here you have to mention the strategy, right? So what should the strategy be? So V is in, let's just write it like this. Yeah. We don't need to write it like this, but yeah. Just like we had T, and then we had reach 1, then reach 2, dot dot dot, and finally we got to, in finite stages, we got the reach. And now we are picking some V which is outside the reach. Yeah. So how do you prove that? Is it intuitively, have any idea, any, like why this, at least expect this to be true? That if your vertex V is outside this, then you can never reach in T, provided player 0 plays with a sensible strategy. That's why maybe it's difficult. That's why you're finding it a bit inconvenient to prove. See, you want to prove that the game always remains in the complement of reach T actually, right? Right. So we want to show, the token always remains in the reach T complement, or same thing. Now actually this will be easier to show. Now you know what to show. So what strategy do you want to give player 0? Well, very simple. The only strategy, right? If V, so if V is in, so strategy is that if V is in V naught, right? This implies, not V naught, yeah. If V is in V naught, and obviously it's in this, that's already standing hypothesis. If V is in V naught, then that we know that then there exists a W in V in the complement, right? Such that there is an edge from V to W. Correct or not? Otherwise, it would have been in reach, right? If all the edges coming out from this V were in reach T, then this V would have been in reach T also, right? Would have been reach T I plus 1, next one, right? Yeah, this happens. So then what do? The strategy will be that when this V comes, you return it to this W, right? Simple picture is like this. Is it right? Correct? This is the strategy. And then player one can play any strategy, it doesn't matter. Right? Because if suppose player zero is playing with this strategy. Now if V is in V naught, if V is in V1, sorry, if V is in V1, then we know that all the edges are in complement of reach T. That implies that for all V comma W in E, W is in complement, and that is again just very simple, because if there was an edge which was in reach T, then V would have been in reach T also. That's the nature of reach T. So this means no matter what player one does, the game will remain in reach. So the game remains in complement of reach T. This has a technical name, but that's not important. Is this any good? You will see that something very simple is going on, but only the language is a little complicated. But this is true in, yeah, that's the relative things. This is true in a large number of cases. That the thing is actually very simple. The idea is very simple. Yeah. And this idea is actually very simple. So any comments? All right. So we are learning just a little bit of game theory. Okay, a little bit. So I think we will not do the repeated reachability. I should have done that. We should have gone a little faster, but no problem. We will do that next time. So now some questions. Do all of you have the, so next time we will do repeated reachability. That will involve some recurrence also. So reason will be nice to prove those things. So do all of you